Hello everyone, this is Bassam and I'm working with Yunyue for the second assignment of the course Computer Applications in Power Systems. We have basically divided our work into two parts, that is k-means clustering and application of k methods to identify the unknown state of power system. So let's start. First, what you see here is that we import the file given into MySQL Workbench, so that we can see the measurement data that is given like this in the table. However, in order to use this in Java, we need to export this table into an Excel file, and then we can read this Excel file in Java. So we click this button up here, the export button, and we can create an Excel file like this. So you see we have all the information that we need, as the tables contains the same information, of course, as the MySQL. Okay, so let's see here. We take a look on the code for reading the external file and store the information from external file into the array list, which we will create, which we have created, of course. Sorry. So first of all, the type of the array list is called the measurement list, or the measurement. And for the measurement, we need another class. So we have created it here with two variables, where one is info and one is envolve. So they are like double array. One is of the type string and one is of the type double. Okay, now we can go deep into the code for reading the external files. So here we use a file reader in order to read an external file from the folder, and then here we divide, or we separate the data into two arrays, because the reason for this is that if you take a look on the given data, it will include some information like RDF ID of bus bar and RDF ID of substation, but actually we don't really need this information for this step. So what we need is actually the value or the measurement that we have. So I divided measurements into two arrays, where one is called info and the other one is called values. After that, what we need to do is to add this readed information which we have got into the array list called MEA list, or the measurement list, as you can see here. So once this loop is done, we have already obtained the data from the array. After we create the database, what we have done here is that we create a new type of array list, which is a value list with the name of the array list as vlist, as you can see. The reason we have created this new type of array list is because we only store the measurement of voltage, amplitude and angle in this array list. So there is practically no information of the RDF ID or the measuring time in this. So in this array list we have that. The reason we have created this is because later we will use it to calculate the distance, and the definition of value list is here. So you see we only have the data of the value, which means the value of voltage, amplitude and angle. Okay, so now what we need to do is to implement the k-means clustering into our Java code for doing this. Basically, we have two steps in total, and the first step is like we give it a first try, and after the first try we will have a loop, and within the loop we will perhaps need to repeat so many times until we have clearly divided 4 clusterings. Okay, let's start. Firstly, we need to create 4 centers, because we have 4 clusterings, and with each of them we have 1 center. So we will have in total 4 centers. So the code is given here. we will have the 4 centers with given value randomly in the first time. After this, we need to calculate the distance between 8 points and 8 center points or centroids, because actually we have 200 points or 200 measurements data, and what we need to do is like to calculate for each of the measurement data distance between this point and the center of one of the clusterings. So the code is like this one for the 200 measurements, and for each measurement we will have one measurement point, and we will have 18 coordinates, because actually we have 9 buses, and for each bus we have voltage amplitude and voltage angle, so it's like 2 times 9 is 18, so 18 coordinates for each point. And here the code is like to calculate the distance between each measurement point and to the center of clustering 0, so it's like called P0. The second one is called P1, center P1, with the same ID, which we calculated for this 200 measurements before, the distance between these 200 measurement point and to the center P1. Also P2 and P3, as you can see, so we have in total 4 centers, and we have calculated for each point distance between this point and one of the center. So then after we can calculate, let's say for each point, now we have 4 distances with respect to centers of the clustering. So then we need to compare the distance, and we need to find the shortest distance. After we find that, we will put this measurement point into the clustering with which we will have the shortest distance. So it's like we have founded the nearest center of this point. So the code for this part is to actually decide which clustering has the nearest measurement point, and we will put this point into the corresponding clustering then. So after that, after we separate all the measurement point into 4 clustering, what we need to do is actually recalculate the new center of the new clustering. So the code for this is like this one. This is the center 0, and this is for center 1. This is for center 2, and so on. After this, we need to divide it, the numbers of the point within each clustering, and then we can calculate the new center address with the corresponding 18 coordinates. Okay, so next, well, until now we have given the first try of the clustering method. We have divided all the measurement, so the 200 measurements data, into the 4 clustering, and then what we need to do is like to repeat these steps. So what we need to repeat this step, we have to repeat this step until the time when the difference between the oldest center and the newly calculated center is very small. So it depends on the criteria that we choose for the difference between the new center and the previous center, because actually the idea is like until the difference is smallest, very small, then we are sure that the clustering is done. In order to calculate the difference of the difference between new center and previous center, what we have done is like we recalculated the center position after each each loop, and then we calculated the difference between the coordinates. And then we have some standards to compare this here. So Lee will now present the second part. Thank you very much.